What propels a tiny species in a forgotten corner of the universe to defy gravity and launch itself into the void? Is it curiosity, pride, or perhaps an ancestral desire to go beyond the known? Since humanity first looked up at the sky, it has dreamed of reaching the stars. And although for millennia that was an impossible dream, today it is a reality that defines our present and will determine our future. This is the story of how we went from worshipping constellations to sending probes to the confines of the solar system, from observing the moon with fear to stepping on it with our own feet, from competing in a political race to dreaming of colonizing Mars. From the beginning of time, humanity has looked upward with a mixture of wonder, fear, and curiosity. The night sky, deep, infinite, and full of twinkling lights, was the first map that human beings tried to decipher. Long before telescopes, rockets, and astronauts, the universe was a sacred mystery. The sun was a life-giving god, the moon a goddess who controlled the cycles, and the stars, divine signs that guided kings and peasants alike. In Babylonia, around 1600 BC, the first astronomers were already recording the movements of Mercury and Venus. They did so not for modern scientific purposes, but as an attempt to understand the whims of the gods. Over time, Mars, Jupiter, and Saturn were also identified, marking the beginning of a millennial relationship between humanity and the cosmos. In ancient Greece, the sky became a philosophical stage. Aristotle imagined a perfect universe with the Earth motionless at the center, surrounded by crystalline spheres that carried the celestial bodies. Ptolemy developed this model and turned it into dogma. 7 planets, the Sun, the Moon, Mercury, Venus, Mars, Jupiter, and Saturn, revolved around the Earth. For centuries, this geocentric idea was considered absolute truth, and those who challenged it risked not only their reputation, but also their lives. But the Renaissance brought with it an intellectual earthquake. Nicolaus Copernicus, a Polish astronomer, challenged the dominant thinking by proposing that it was not the Earth, but the Sun, at the center of the system. The heliocentric idea forever changed our understanding of the universe. Shortly after, Galileo Galilei pointed a telescope at the sky for the first time and discovered moons orbiting Jupiter, proving that the Earth was not the navel of creation. For his discoveries, he was persecuted by the Inquisition, but the seed of change was already planted. At the beginning of the 17th century, Johannes Kepler refined Copernicus's vision with his laws of planetary motion, describing elliptical orbits and variable speeds. And in 1687, Isaac Newton explained universal gravitation, an invisible force that kept the planets in their trajectories. Physics was born as the language of the cosmos, and with it, the possibility of one day escaping Earth. Each of these ideas, from Sumerian myths to Newtonian mechanics, was a step on a path that we have not yet finished traveling. But back then, everything was still theory. Humans could not imagine that centuries later their descendants would stop looking at the sky to go and conquer it. For centuries, the sky was an unattainable stage. Men could observe it, worship it, and interpret it, but never touch it. However, the desire to fly, that obsession that mixes ambition, curiosity, and madness, never disappeared. In 13th century China, BC, alchemists discovered gunpowder and began experimenting with rudimentary rockets. They were not spacecraft, of course, but those projectiles that ascended a few meters were the first step on the long ladder to the stars. Even Leonardo da Vinci, long before modern engines or aerodynamics existed, imagined machines capable of lifting humans into the heavens. His sketches of mechanical wings and flying devices were a testament to human ingenuity, although it would be centuries before they became a reality. The idea of leaving the ground was still a dream, but it had already germinated in the human mind. The 20th century changed everything. 3 men, separated by thousands of kilometers but united by the same obsession, laid the foundations for exploration. The Russian Konstantin Tsiolkovsky, the American Robert Goddard, and the German Hermann Oberth. Tsiolkovsky was the visionary. In 1903, he published a revolutionary book in which he stated that humans could leave Earth using propulsion devices. He even calculated the speed needed to escape Earth's gravity and proposed the use of liquid oxygen and hydrogen as fuels. Robert Goddard, inspired by these ideas, took the next great leap. In 1926, in a field in Massachusetts, he launched the first liquid-fueled rocket in history. Its flight lasted barely 2 seconds and ended in a cabbage patch, but it marked the beginning of the space age. Shortly after, Hermann Oberth took these ideas further, perfecting rocket design and laying the groundwork for the technology that would propel humanity off the planet. Physics also played its part. In 1915, Albert Einstein published the theory of general relativity, revolutionizing our understanding of space, time, and gravity. His ideas, combined with Newton's, explained how the fabric of the universe curved and how objects could move within it. Unknowingly, Einstein was writing the manual that would allow future generations to travel beyond the atmosphere. Each advance was another step closer to the sky. Humanity was ready to stop dreaming of flying and start building the machines that would make it possible. The 20th century was just beginning, and with it, the greatest race in human history, the conquest of space. Space exploration was not born in a peaceful laboratory or a quiet observatory. It was born in chaos, in the heat of the bloodiest conflict in history, World War II. It was in the midst of destruction that science took one of its most audacious leaps. Rockets, originally designed as weapons, became the first tools capable of breaking the chains of Earth's gravity. During the war, Germany developed the V-2, the first long-range ballistic missile. That lethal machine, created by engineers like Hermann Oberth and Wernher von Braun, could reach heights never before seen by a human artifact. On June 20, 1944, a V-2 became the first man-made object to cross the boundary of space. It carried no astronauts or cameras, only the weight of human knowledge propelled by destruction. When the war ended, the world was divided into two irreconcilable poles. The United States and the Soviet Union, former allies against fascism, became ideological rivals in a confrontation that needed no bullets to be the Cold War. Capitalism versus socialism, freedom versus control, West versus East. But beyond politics and nuclear weapons, the new battlefield would be the cosmos. The conflict pushed both superpowers to invest enormous resources in science and technology. Advances in missiles became the basis for future space rockets. In 1946, an American V-2 equipped with a camera took the first photograph from space, a blurry but historic image in which the curvature of the Earth was revealed for the first time. The space race had begun, although the world did not yet know it. In 1947, the United States launched the first life forms into space, simple fruit flies that survived the journey. 2 years later, Albert II, a rhesus monkey, became the first primate to reach beyond the atmosphere, although he did not return alive. 2 out of every 3 monkeys sent during that period died during the mission or shortly after, a brutal reminder that space does not forgive mistakes. Meanwhile, in the Soviet Union, one man would change the course of history, Sergei Korolev. In the 1950s, he developed the R-7, the first intercontinental ballistic missile, which would soon become the basis for Soviet space rockets. With it, the Sputnik program was born, the first chapter of a competition that would redefine not only science but also the destiny of humanity. Space exploration had ceased to be a romantic dream. It was now an instrument of power, a symbol of national superiority, and a geopolitical gamble. And although the sky remained the same, the race to conquer it was just beginning. On October 4, 1957, at 7:28 a.m., an object the size of a beach ball streaked across the sky at over 28,000 km/h. It was Sputnik, the first artificial satellite in history, launched by the Soviet Union. Its mission was to emit a beep from orbit that any amateur radio operator could hear. But that repetitive, monotonous sound was much more than an experiment. It was the heartbeat with which the space race officially began. For the United States, that beep was a humiliation. The most powerful country in the world had been technologically surpassed by its ideological rival. President Eisenhower spoke of a Sputnik crisis, and in response the U.S. government created NASA on July 29, 1958. The message was clear. They would not lose this competition. The USSR, however, did not stop. A month after Sputnik 1, it launched Sputnik 2, which carried aboard Lika, a stray dog from Moscow. Her death, caused by the capsule overheating, was concealed for years, but her sacrifice opened the doors to a new era: exploration with living beings. Despite the risks, the message was unequivocal. If a dog could survive in space, even for a short time, perhaps a human could too. On April 12, 1961, humanity took a giant leap. Aboard the Vostok 1 spacecraft, cosmonaut Yuri Gagarin became the first human to leave Earth. "I see the Earth. It is blue," he exclaimed as he orbited our planet. Gagarin returned safely after 108 minutes in space, becoming a global hero. The Soviet Union had achieved the unthinkable, and the United States was once again left behind. But American pride would not take long to react. Just a month later, on May 5, 1961, Alan Shepard became the first American in space, and President John F. Kennedy, determined to regain the lead, issued a challenge that would define a decade. "Before this decade is out, of landing a man on the moon and returning him safely to the Earth." From then on, the race ceased to be a simple technological duel. It became an ideological symbol. Two political systems clashing for dominance of the future. The USSR launched more satellites, more animals, and more automatic missions. The United States responded with increasingly ambitious programs: Mercury, to put men in orbit; Gemini, to perfect maneuvers in space; and finally, Apollo, the project that would take humanity to another world. Space was no longer a distant dream. It was a silent battlefield where prestige, science, and power were at stake. And on that cosmic chessboard, both giants knew that it was not enough to arrive. They had to go further. On May 25, 1961, before the United States Congress, John F. Kennedy uttered one of the most audacious phrases in modern history. "Before this decade is out, of landing a man on the moon and returning him safely to the Earth." It was not just a political speech. It was a declaration of scientific war. The United States set out to achieve the impossible and defeat the Soviet Union on the grandest stage of all, the cosmos. The race to the moon began with stumbles. The Mercury project allowed the Americans to put men in orbit, but it was just a first step. Then came the Gemini project, which perfected vital techniques such as docking spacecraft in space and extravehicular walks. Each mission was a dress rehearsal for the grand spectacle to come. In 1967, however, tragedy struck NASA. During a ground test, a fire in the cabin of the AS-204 mission, later known as Apollo 1, killed astronauts Gus Grissom, Ed White, and Roger Chaffee. It was a devastating blow. The program was halted, and the lunar dream was in jeopardy. But the goal remained, and with renewed determination, NASA redoubled its efforts. The Apollo 7, 8, 9, and 10 missions served as technical and psychological stepping stones. Apollo 8 took humans to orbit the moon for the first time, while Apollo 10 practiced the descent without touching the surface. Everything was ready for the final step. On July 16, 1969, millions of people around the world held their breath. From Cape Canaveral, the Saturn V rocket lifted off, carrying Neil Armstrong, Buzz Aldrin, and Michael Collins. 4 days later, the lunar module Eagle separated from the main spacecraft and began the riskiest descent in history. With fuel running low and the terrain littered with rocks, Armstrong took manual control and searched for a safe spot. At 20:15 UTC on July 20th, the message reached Earth, "The Eagle has landed." Hours later, at 2:56 UTC on July 21st, Armstrong descended the ladder and stepped onto the dusty surface of the Moon. His phrase was etched into collective memory. "That's one small step for a man, one giant leap for mankind." Beside him, Aldrin joined shortly after, while Collins orbited in solitude in the command module. The Apollo 11 mission was watched by over 1 billion people. The United States had fulfilled its promise. It not only reached the Moon, but did so before 1970. During subsequent missions, astronauts placed scientific instruments, collected samples, and left footprints that remain intact on the lunar surface to this day. The giant leap marked not only the American triumph in the space race, but also a turning point in human history. For the first time, we had left our home planet and set foot on another world. And with that, the exploration of space ceased to be a competition and became a destination. Apollo 11 had fulfilled the oldest dream of humanity, to walk on another world. But once the astronauts left their footprints on the lunar surface, a new question arose. What now? The Moon, devoid of atmosphere, life, and significant resources, offered few secrets to uncover. The real treasure lay beyond, in the vast cosmic ocean that stretched towards the planets, asteroids, and stars. After the lunar missions, space exploration changed course. Instead of sending humans, agencies began sending machines, cheaper, safer, and capable of reaching much farther. In the 1970s, the Soviet Union launched the first space stations. Salyut 1 was inaugurated in 1971, becoming an orbiting laboratory where cosmonauts could live and work for weeks. It was the first step towards a permanent human presence in space. Meanwhile, robotic probes became silent explorers of the solar system. The Lunokhod mission sent a small vehicle to roam the lunar surface, while Pioneer 10 in 1973 was the first to reach Jupiter, studying its atmosphere and magnetic field. A year later, Mariner 10 used an innovative maneuver called a gravitational assist to visit Venus and Mercury, capturing unprecedented images of both planets. In 1975, the Venera 9 mission landed on Venus and took the first photographs from the planet's surface. A year later, Viking 1 did the same on Mars, sending back images that revealed a desolate but fascinating world. For the first time, humanity had eyes on other planets. And then a name appeared that would mark a before and after: Carl Sagan. His vision went beyond science. He imagined the cosmos as a place full of potential neighbors. If life existed on other worlds, how could we communicate with it? From that question, the Voyager mission was born. Launched in 1977, the Voyager 1 and 2 probes explored Jupiter, Saturn, Uranus, and Neptune, and carried with them the famous Golden Record, a time capsule with greetings in 55 languages, sounds of Earth music by Bach and Chuck Berry, and photographs explaining who we are and where we come from. In 1990, Voyager 1 left the solar system, and by 2020, it was more than 22 billion kilometers from our planet. It is the most distant human-made object in existence, a solitary ambassador traveling among the stars. During these decades, space became a laboratory, a museum, and a mirror. We learned about the atmospheric composition of other planets, the history of the solar system, and the fragility of our own existence. Humanity understood that, compared to the cosmos, our world is but a pale blue dot floating in the darkness. Exploration was no longer a power play between nations. It was a collective endeavor of human knowledge. And although we had advanced as never before, the universe still held dangers that would remind us how far we were from mastering it. Exploring space was never a safe journey. Every advance was tainted by risk, uncertainty, and often tragedy. For every probe that reached a distant planet, there was another that was lost in the void. For every successful mission, there was a story of human sacrifice that reminded the world that out there, error is unforgiving. The first major reminder came on January 28, 1986. The Space Shuttle Challenger lifted off from Cape Canaveral under the watchful eyes of millions. Just 73 seconds after launch, a failure in the O-ring seals of a booster rocket caused a devastating explosion. In an instant, the craft disintegrated in the sky, and the 7 crew members perished. Among them was Krista McAuliffe, the first civilian teacher chosen to travel to space. The disaster paralyzed the American space program and forced a reassessment of every safety protocol. The message was clear. Space had no room for complacency. 3 years earlier, in 1983, the Soviet mission Soyuz T-10-1 had suffered a fire on the launch pad. Just seconds before the explosion, the escape system activated and saved the cosmonauts' lives in a technological miracle that set a precedent. However, second chances were not always available. Despite the tragedies, exploration continued. In 1990, the launch of the Hubble Space Telescope represented a new leap for astronomy. It would orbit outside Earth's atmosphere, offering undistorted images and allowing observation of the universe with unprecedented clarity. But even this technological marvel had a rocky start. An error in the polishing of the main mirror left its first images blurry, forcing a repair mission in orbit 3 years later. After its correction, Hubble revealed cosmic wonders never seen before, forming nebulae, distant galaxies, and the iconic image of the pillars of creation. In parallel, the Mir space station was breaking records for human permanence in orbit. Between 1994 and 1995, cosmonaut Valery Polyakov spent 437 days in space, the longest period in history. His mission provided insight into how the human body changes in microgravity. Muscles weaken, bones lose density, senses atrophy, and even the mind struggles against loneliness and isolation. Space was not only physically hostile, it could also be psychologically breaking. But the greatest reminder of our vulnerability came on February 1, 2003. The shuttle Columbia disintegrated upon re-entering the atmosphere after a 16-day mission. A piece of insulating foam had damaged its left wing during launch, compromising its structure. The 7 astronauts on board lost their lives. It was a devastating blow to NASA and to all of humanity. Each accident left scars, but also lessons. Space exploration moved forward, more cautious and better prepared, but with the certainty that every mission was a gamble at the limits of possibility. And although the price was high, the reward was even greater, opening the doors of the universe. With the end of the Cold War and the dissolution of the Soviet Union in 1991, space ceased to be an ideological battlefield. For the first time since the beginning of the space race, the cosmos became a field of international cooperation. What was once a fierce competition between 2 superpowers was now transforming into a global scientific alliance. The enemy was no longer the other political system, but the vastness of the universe itself. In this new context, the most ambitious project in exploration was born, the International Space Station. Its construction began in 1998 with the participation of more than 15 countries, including the United States, Russia, Japan, Canada, and several European nations. The objective was simple in theory but monumental in practice: to create a permanent laboratory in orbit where scientists could study everything from the behavior of the human body in microgravity to the growth of crystals and bacteria outside of Earth. The ISS marked a before and after. It was not only an engineering feat larger than a football field and visible from the ground, but also a symbol of human collaboration. Astronauts of different nationalities shared missions, knowledge, and resources. Even countries that had never had a presence in space found their opportunity. In 2006, Brazil signed an agreement with NASA that allowed the sending of the first Brazilian astronaut, Marcos Pontes, who also became the first South American and Portuguese speaker to travel to space. Meanwhile, space agencies began to focus on studying the biological and psychological impact of prolonged stays outside of Earth. long-duration missions revealed surprising changes in the body: loss of muscle mass, bone weakening, alterations in the immune system, and a slight expansion of the spinal column that could make astronauts grow up to 3% taller. However, one of the most concerning effects was the psychological impact. Extreme isolation, monotony, and distance could lead to depression, anxiety, and even self-destructive thoughts. Space exploration also began to be democratized. New players entered the scene. Agencies like Japan's JAXA, Europe's ESA, or Canada's CSA took on fundamental roles in scientific missions. Collaborations allowed for the construction of more powerful telescopes, the sending of probes to distant planets, and the sharing of data that was once state secret. This paradigm shift opened the doors to a different future. Space ceased to be the property of a few and became a common project of humanity. It was no longer about planting flags or displaying military might. It was about better understanding our place in the universe and preparing the way for what would come next. Expansion beyond Earth's orbit, towards other worlds. And although the Moon had already been conquered, the next destination was clear from the beginning. Mars, the red planet, awaited silently for humanity to gather the courage and technology necessary to reach it. Once international cooperation was consolidated, space exploration once again looked outward. If the Moon had been a symbol of conquest and Earth's orbit a learning laboratory, Mars became the next great objective. The red planet, always visible in the sky as a mysterious orange dot, promised answers about our past and perhaps our future. The first probes sent to Mars in the 1970s, like Viking 1 and 2, had shown an arid, icy world with gigantic canyons and colossal volcanoes. But with technological advancement, new generations of robotic explorers took the investigation much further. In 1997, the small Sojourner rover rolled across the Martian surface, paving the way for more ambitious missions. Years later came Spirit and Opportunity, which traveled kilometers of terrain, analyzed rocks, and revealed evidence that liquid water once flowed on that planet. But the jewel of this new era was Curiosity, which landed on Mars on August 6, 2012. Equipped with instruments capable of analyzing the soil, measuring the atmosphere, and searching for organic compounds, this rolling laboratory completely transformed our understanding of the planet. It discovered ancient riverbeds, detected molecules essential for life, and measured radiation on the surface, key data for a future crewed mission. Every finding fueled a question that science still could not answer. Was there life on Mars? The exploration of the cosmic neighborhood was not limited to the red planet. In 2010, the Japanese mission Hayabusa achieved something unprecedented, collecting samples from an asteroid and bringing them back to Earth. 4 years later, in 2014, the European probe Rosetta landed on Comet 67P Churyumov-Gerasimenko, becoming the first spacecraft to touch the surface of one of these icy bodies. These achievements allowed for the study of the origins of the solar system and the role that comets and asteroids may have played in transporting water and organic matter to early Earth. Asteroids also sparked new economic interest. Some, like 16 Psyche, are composed almost entirely of valuable metals such as iron, nickel, and platinum. Their estimated value exceeds $10 quadrillion, which has led agencies and private companies to plan future space mining missions. At the same time, space telescopes were revolutionizing our view of the cosmos. The Kepler telescope, launched in 2009, was dedicated to searching for exoplanets, worlds orbiting other stars, discovering more than 2,700 of them. Some were gas giants, others rocky worlds similar to Earth. The most promising, Kepler 452b, is up to 5 times larger than our planet and is located in the habitable zone where liquid water could exist. The idea that we are not alone in the universe ceased to be a dream and became a real scientific possibility. Every mission, every robot, and every image sent from millions of kilometers away brought humanity a little closer to answering its questions. Where do we come from? Are we alone? And how far can we go? The near universe was still full of mysteries, but one thing was certain: the exploration was just beginning. For more than half a century, space exploration had been the exclusive domain of governments. Decisions were made in presidential offices, budgets depended on political will, and achievements were symbols of national pride. But in the 21st century, a new type of actor burst onto the cosmic stage: private enterprise. And with its arrival, a revolution began that would forever change the way humanity reaches space. It all began in 2002, when a young entrepreneur named Elon Musk founded a company with an objective as ambitious as drastically reducing the cost of space launches and one day taking humans to Mars. That company was SpaceX. In its early years, Musk even tried to buy obsolete Soviet rockets to start his projects, but when he couldn't get them, he decided to build them from scratch. His philosophy was, if space was too expensive, the industry had to be reinvented. In 2010, SpaceX introduced its most emblematic creation, the Falcon 9, a partially reusable rocket. Until then, every launch was literally single-use. Millions of dollars were lost on parts that fell into the ocean or disintegrated in the atmosphere. But the Falcon 9 changed the paradigm. Its first stage, the most expensive part, could return to Earth and land vertically to be reused in future flights. This breakthrough reduced launch costs by more than 70% and opened the doors to a sustainable business model. The impact was immediate. With over 200 successful launches, SpaceX not only became the leading provider of commercial satellites, but also a strategic partner of NASA for transporting cargo and astronauts to the International Space Station. In 2018, the company took this philosophy to another level with the launch of the Falcon Heavy, the most powerful operational rocket in the world. As a symbolic payload, Musk placed his own Tesla Roadster inside, with a mannequin named Starman, listening to David Bowie's EU Space Oddity, as it orbited the Sun. The image became iconic. Space was no longer just science, it was also a spectacle. Competition was not far behind. Amazon founder Jeff Bezos launched Blue Origin with the goal of democratizing suborbital space travel. In 2021, Bezos traveled to space in his own craft, financed, in his words, by all of Amazon's customers. The phrase was controversial but revealing. Access to space was ceasing to be a state project and becoming a business. This new race no longer pitted countries against each other, but companies, and their goals went far beyond orbit: asteroid mining, space tourism, colonization of Mars. The private industry was proving that exploration could be profitable and revolutionary at the same time. The sky that once belonged to nations was now an open market. However, this privatization of the cosmos also raised questions. Who will own the resources of space? What laws will govern on Mars? And what will happen when the goal is no longer science but economic profit? What is clear is that the era of government rockets is over, and in its place, a new gold rush among the stars has been born. If the 20th century was the time of pioneers and superpowers, the 21st century is the era of the impossible made real. Humanity is no longer content with orbiting Earth or visiting the Moon. Now it wants to understand the universe, harness its resources, and even inhabit it. And with each passing year, the limits that seemed insurmountable blur a little more. In 2014, the European Space Agency achieved a milestone that seemed like science fiction, landing the Philae probe on Comet 67P Churyumov-Gerasimenko. It was the first time a human-made object had touched one of these icy bodies, allowing for the study of its components and the role they may have played in the origin of water and life on Earth. That same year, scientists began to focus their attention on another fascinating target: metallic asteroids, true treasure chests floating in space. The most famous, 16 Psyche, contains iron, nickel, platinum, and even gold, worth an estimated more than $10 quadrillion. far exceeding the entire world economy. In 2015, the New Horizons mission performed the first flyby of Pluto, demonstrating that even a dwarf planet could reveal surprising secrets about the formation of the solar system. That same year, SpaceX achieved one of its most revolutionary accomplishments. The first stage of the Falcon 9 landed vertically after completing its mission. This reusability capability changed the rules of the game forever, reducing costs and multiplying the number of possible launches. But the most symbolic moment of this new era arrived on February 6, 2018. To test the power of the Falcon Heavy, Elon Musk used his own Tesla Roadster as payload. With a mannequin nicknamed Starman on board, the car was launched into space while David Bowie's Space Oddity played, becoming a symbol of human ingenuity and space marketing. Today, it still orbits the Sun, reminding us that the universe is no longer just a scientific destination, but also a cultural and commercial one. The technological revolution did not stop there. In 2021, Jeff Bezos traveled to space with his company Blue Origin, marking the beginning of a new era. Space tourism. What was once the privilege of a few highly trained astronauts was now beginning to be within reach. Very expensive, yes, of wealthy civilians. The sky was literally for sale. And while private companies compete, science continues to advance. The James Webb Space Telescope, launched on December 25, 2021, represents the most ambitious leap in observing the universe since Hubble. Capable of capturing infrared radiation and looking back in time to the first few hundred million years after the Big Bang, the Webb is rewriting our understanding of the formation of galaxies, stars, and planets. Its first images, presented in July 2022, revealed a cosmos more complex, vaster, and more beautiful than we ever imagined. The future is no longer a distant dream. It is here. Missions to Mars are in development. Asteroid mining is a real economic possibility, and telescopes allow us to glimpse the dawn of the universe. Each achievement brings us one step closer to the day when living on another planet ceases to be science fiction and becomes a tangible option. But with each advance, a new question also arises. Are we prepared for what we will find out there? The universe does not wait for us. It expands, evolves, and continues on its course, indifferent to our ambition. The question is not whether we will go further, but whether we will know what to do when we get there. For thousands of years, the sky was an unattainable mystery. Then it became a map that guided sailors, a laboratory for scientists, and, finally, a stage for human ambition. Today, in the 21st century, the universe is no longer just a destination. It is the next chapter of our history. And the most amazing thing is that this story is just beginning. Space exploration has gone through all its stages. The primitive wonder of the first observers, the scientific curiosity of the Renaissance, the ideological race of the Cold War, the international cooperation of the late 20th century, and the business revolution of the present. Each of these phases has left indelible marks. We have launched satellites, walked on the moon, sent probes beyond the solar system, landed on comets, and dreamed of human colonies on Mars. What once seemed impossible is now discussed in laboratories, conferences, and boardrooms. But the horizon continues to expand. Scientists are no longer thinking only of Mars, but also of the moons of Jupiter and Saturn, where there could be subterranean oceans with conditions favorable for life. Planned missions to explore Europa, Enceladus, or Titan could answer one of the deepest questions of humanity. Are we alone in the universe? At the same time, projects like NASA's Space Launch System or SpaceX's Starship aim to take us further than ever, preparing the ground for interplanetary and even interstellar journeys. Knowledge is also advancing at a dizzying speed. Thanks to telescopes like James Webb, we can look into the cosmic past and study the first galaxies that formed after the Big Bang. And as we observe, we realize that each discovery is not an endpoint, but a new beginning. The universe is not a place we come to conquer, but an infinite ocean that we are just beginning to navigate. However, the future of space depends not only on technology, but also on us. What will we do with the knowledge we acquire? Will we use the cosmos to unite as a species, or will we turn it into another battlefield for power and resources? Space exploration is not just a scientific feat. It is a mirror of our humanity, of our virtues, and our flaws. The truth is that the destiny of humanity is no longer tied solely to Earth. Every mission, every discovery, and every step beyond our atmosphere is an invitation to look up. And what comes next? The universe awaits us, immense, mysterious, eternal. And it challenges us to keep exploring, not because it is easy, but because it is our destiny. Today, as telescopes like the James Webb look towards the confines of the universe and private companies plan colonies on Mars, the human spirit remains the same as it was when it looked at the stars thousands of years ago. Only now, instead of asking what is up there, we are learning to go and find out for ourselves. Perhaps one day our descendants will be born on another planet, under a sky with two suns, or in orbit around a distant star. When that happens, they will remember that it all began with a small act, looking at the sky and wondering what lay beyond. Space exploration is not a luxury or a scientific curiosity. It is the natural destiny of humanity, because as long as there are stars in the sky, we will keep trying to reach them.